Hello and welcome to a new series on ACI. My name is Sean Gomez and I'm a systems engineer at Cisco. I've been working on data center designs and implementations for the better half of my career. Today, we're going to talk about getting started with Cisco Application-Centric Infrastructure, otherwise known as ACI. This will be the first video in a series that I'm creating to help make deploying ACI as easy, painless, and seamless, but also fun. This is especially true for small POV environments. If you're going to be working on an environment like that, this is definitely a video that could help save some time. As with any large data center technology undertaken, we really recommend working with an authorized learning partner such as Skyline, NetMasterClass, to gain a deep insight on ACI, as no two customer environments are ever the same. Also, partners, Cisco VARs, professional services can also assist with migration and implementation, and is highly recommended. With that said, and the disclaimer out of the way, let's roll up our sleeves and have some fun with bootstrapping ACI. Now, a couple things. When we start talking about the fabric provisioning, this sounds like a major undertaking. Oh my goodness, I got to provision the fabric. And in all sincerity, this is actually the easy part. It's the overlay, it's the policy. That's when things start getting a little more complicated and a lot more thought process has to go into it. But when you talk about the fabric provisioning, let's kind of just take a step back and say, what are we trying to accomplish with ACI? Well, one of the big things is automation orchestration. It's a big theme that we see in IT today, and we, quite frankly, need to get away from a box-by-box approach, especially in large, scalable data center designs, where box-by-box approach, even using some scripting tools, may not be the best way to operate data center infrastructure. So when you look at ACI, we got a couple things, and I'll put some links on the YouTube video, clickable links that you can hit and access these documents that I'm sharing on my screen. But basically, we have a clustered logical, centralized, but physically distributed APIC controller. Now, that's a mouthful. What does that actually mean? Well, you have a redundant APIC cluster that could either be geographically in one location, or you can spread them out across multiple locations. But in the end, you have a single centralized location for all fabric policy, bootstrapping, image management for the entire infrastructure, for the entire fabric. Now, when we go through this bootstrap process for ACI and provisioning the fabric, you'll see that a lot of what we're doing is actually automating what we would call the underlay. So the underlay network, we're going to try to automate the configuration of that as much as possible so that you're not configuring routing protocols, setting up a DHCP server, things like that. Discovering the fabric itself, we basically will go through this here as well, where we're saying when we use the auto discovery process, we're allowing you to create this underlay infrastructure, automate the configuration, and things like the ISIS protocol, which is running underneath the covers. You don't have to go in there and configure manually. You don't have to tweak timers and tune it. It's already to Cisco's best practices for the fabric. We're using LLDP, Link Layer Discovery Protocol, to discover each node on the fabric itself. So the leaf, the spine nodes, and the APIC controller, we're discovering that through LLDP. And of course, the end host. Then we're using internally DHCP to assign addresses to the infrastructure, to the underlay, the tunnel endpoints. And you'll see that as we go through some of the startup script. But in the end, we're trying to provide a simple and automated policy-based provisioning system that allows for easy upgrade processes and automate the image management. At the end of the day, you could lose all 3 APIC nodes and your data center is not going to fall apart. It's not going to come crashing down because we're not bringing the control plane to a central location. This is a policy engine. So if you lost all 3 in a catastrophic failure, then your data center will continue to operate as it was at this time of the loss, right? You can't make any new changes to the policy, the configuration, but everything will continue to forward as it was at the time of the failure. So with that said, let's go into some of this information. Let's go into some of the details. Very first thing we want to start with, let's start talking about physical cabling, right? So sometimes you read these provisioning guides and it can be a little confusing. So let's just kind of clarify how we get into the APIC to do the initial configuration. So I'm going to bring up an illustration here to make things a little bit easier. And this is my best attempt at drawing the back of a UCS server, right? It's the APIC controller. It really is, at the end of the day, a UCS C-Series 1RU server. But on the back, you have a couple connections. And starting from the left, you have that blue port VGA, right? Get your video output. Pretty straightforward. And then we have this green port that has binary, 10101 on, off, on, off, on. That's representing the actual console port. So think of that as like a console port on a normal switch, a normal router. You use a rollover cable. You connect the rollover cable to it, and you're good to go. So that RJ45 console, you could hook up a console cable, and that's actually how I have the lab set up here. But that's not the recommended way to do this, and I'll explain why. We also have Cisco Integrated Management Controller, SIMC. That's similar to DRAC on a Dell or ILO on an HP server, and that allows us to have out-of-band management, lights-out management. So the server could be off, you could still reach this IP, you could turn the server on, you can do some low-level configuration of the server itself. But SIMC is definitely what we recommend. And what you can do is you can set up SIMC, give it an IP address, and then once you have an IP address, you can actually connect to SIMC, open KVM, and then go through it just like I'm going through the console here. And all that detail is in the document that I'm going to share. So SIMC is the preferred method. If it's a lab and a POC, you can always hook up an RJ45 cable. It's not going to be the end of the world. And then to the right of that, so the SIMC port is identified with the M on the back of the server. So again, going from left to right, the second RJ45 port from the left has an M indication on top of that. That's the SIMC management IP, or the SIMC interface. Then we have out-of-band management. Now that OOB management is actually for APIC. So let's say you wanted to get to this APIC controller directly. You could create an out-of-band IP so that you could reach this controller versus the virtual IP that's shared across all the cluster nodes. And then finally on the top right, you have the 10 gigabit interfaces that connect to the actual fabric itself. Those are labeled ETH2-1 and ETH2-2. So let's get that out of the way here. And this is the document that I'll be sharing the link in YouTube. You'll be able to click it. And this is basically what we're going to use as we go through this interactive setup. So without further ado, I am going to go right in here. And the first thing it asks, now you could just take the defaults for all this. The default values will work. If any time you have a typo and you want to start this over without restarting the actual server and waiting for that to boot, you can hit Control-D at any time, and it'll start this. It'll start the setup utility from the beginning. So let's go ahead and go through and give it a fabric name. So in my lab, I'm going to call it ACI Lab. Fabric ID is going to be 1. The number of active controllers. Now, 3 is what we recommend, right? So if this is a POC, you're doing this in a lab, you can get away with 1 controller, but in production, minimum of 3 is required. So I'm going to keep 3 because I can add down the road if I wanted to. I can start with 1 and add 3. Enter the pod. This is for multi-pod. We're not setting up multi-pod. You can read more about multi-pod in the links that I send, but we're going to go with the default of 1 here since we only have 1 pod. is this a standby controller? So you could actually have 3 active controllers, and the key word here is active. They're sharding data across all 3 nodes at any given time. You could lose 1. You could still be operating. You could lose 2. You'd be in a read-only mode. But we can have this concept of a standby controller, that when an active fails, a standby is ready to take over. That is what this is asking for, and we do not have a standby in this environment. So I'm going to go with no, or the default. It's case sensitive, obviously. So I did not know that. Controller ID, this will be controller number 1. The controller name, I'm okay with APIC 1 as the default name here. So if we had 3 controllers, the next one would be 2. Probably the next name would be APIC 2. The third one would be controller ID 3. Controller name APIC 3. Enter a TEP pool. Now this is where things start getting pretty, I don't want to say intense, but this is where we need to be very vigilant on what we use for these for this address pool. Now, tunnel endpoint is what this is standing for, and this is the underlay fabric, or the underlay infrastructure, the underlay network. We want to make sure that this is not overlapping with anything that's in production or will be in production. Even though this VRF is called the infra VRF and it's separate, we still don't want to run the risk of this overlapping with anything in production. So what we are recommending, and you'll see this in the setup guide as well, we want you to use a non-overlapping pool with at least a /16. Now, this is basically saying 10, 0, anything, anything. That may overlap in an environment you have, right? So I'm going to go with something a little bit different here. I'm going to go with 172. And I'm going to go with, yeah, let's do 172.31.00/16. And that's just a subnet that I know is not being used anywhere else in my environment. So I'm going to accept that. You can, if 10.0.00/16 is not in use, feel free to use that. Next one is the VLAN ID for the infrastructure network. This is probably the most important one to get right out of the gate and to plan ahead for. And the reason I say that is this VLAN ID cannot be changed without rebuilding the fabric. So, one more time, this VLAN ID cannot be changed without completely rebuilding the fabric. So please use something that is not in use anywhere else. This is used as a VLAN ID that APIC will communicate with the switches, both the spine and the leaf, but also virtual switches. So in my environment, I know I am not using 890, and that's what I'm going to go with. Multicast pool. This is for the underlay. This is for multicast. Basically, we're setting up multicast for you at the underlay to make sure that multicast forwarding is working. And as long as this is not being, yeah, this one actually it can be used. I don't think there's any exceptions on this. Let me go through and just verify that. Yeah, other than the prefix length must be a 15, giving you 128,000 usable IPs. This is acceptable. So I'm going to go with 225.0.0.0, the default, /15, because I don't have any custom multicast groups that are using that. Out of band management, I don't want to use IPv6, so I'm going to say no on this one. Use the default. And I do want to have an IPv4 address, so I'm going to go with, for this guy, 192.168. And instead of 10.1, I am going to go with 7.1/24. Yes. Default gateway is going to be 192. Now, let's see what happens. Okay, there we go. I thought I had to actually do the Control D. So I'm going to do 192.168, 7.254. duplex. I'm okay with leaving that interface in auto. I don't want to force speed here as 1 gig full. I'm just going to go with auto. Do I want to enable strong password? No, not for my lab, but in a production environment, you probably do want to do this. And the password for admin is going to be something easy. Now, this is where it's saying the configuration will be applied. TEP address pool, VLAN ID, multicast pool cannot be changed later. So this is important because I was stressing about the infrastructure VLAN ID, but now this is saying the TEP pool, the VLAN ID, and the multicast pool cannot be changed later. Keep in mind, this is all for the underlay, not for the overlay. And this will result, if you needed to change these, you would have to completely rebuild the fabric. So like I said earlier, take some time, plan this out properly, use the right IPs, use the right IP pools, and use the right VLAN ID. I don't want to make any changes. I want to go ahead and commit this. And it's configuring the network now. Alright, so let's pick up where we left off. Now, number one, I apologize for the background noise. After the APIC setup wizard that we went through, and it was configuring the network, you have to give it about 15 minutes for that configuration to take on the APIC that you're configuring. You also, at that point, when it's done configuring, you're going to want to connect your physical network up to the APIC. So that's where hopefully you had your spine and your leaf switches cabled with 40 gig between the spine and the leaf, or 100 gig, or however you're setting that up. But then you're going to want to take the connection from the APIC itself, and let's go back to this diagram, from the fabric interfaces ETH22 or 21, and you're going to want to connect that to the leaf switch. At that point, now the auto discovery process starts occurring of the fabric. So this is what I did. I waited about 15 minutes after I was done with the setup, and then I logged in with the credentials that I specified, and I ran a very short command here, just show controller, and this shows me the configuration actually took fabric name, ACI lab, operational size is 1. That means I have 1 active APIC controller. My cluster size, I'm expecting 3. And then my TEP pool that I created, and my out-of-band management IP, which is 192.168.7.1. Now, if I go back to that diagram, remember I said OOB MGMT, ETH1 and ETH2. Those are basically going to be sharing that IP address. So the 192.168.7.1 is a failover pair between these two, ETH1 and ETH2. So just keep that in mind as you set this up. And each APIC controller, you're going to want to give a unique IP for the out-of-band management. So the next controller ID would have been 2. We want to give it, let's say, we would go with 192.168.7.2. Next one would be ID 3, 192.168.7.3. Okay. So we have our physical connectivity mapped out. We should now have our leaf and spine switches connected. We should have the APIC connected to a leaf switch. That's key. It has to be connected to a leaf switch. And at this point, everything looks healthy, our configuration accepted, and if all goes well, I should be able to log into the APIC GUI. So here's the IP, HTTPS, so port 443, 192.168.7.1, and I'm going to log in with the credentials I specified. And there we go. We are in the APIC GUI. Now, on the top, well, you got a couple things. You got a screen that shows up what's new. I am running a bleeding edge version of code, ACI 3.0. So it's giving me, hey, this is what's new, multi-site. You know, that's one of the big enhancements that we put in to 3.0. And then it has your videos getting started, GUI, tour. Like I said earlier, the underlay is the easy part. It's the policy and the overlay that's where things get a little more tricky. Excuse me. So I'm going to close this out. And I got this nasty warning yelling at me. What is he saying? He's saying, The cluster contains less than 3 in-service controllers. Basically yelling at me because I specified a cluster size of 3, but there's only one node up and operational, only one active APIC. So in a production environment, like I said earlier, you're going to have 3 as a minimum in your active cluster. And in this case, it's a lab, so I'm okay with that. And here we go. I am in APIC, and as you can see, I don't really have anything set up. So the first thing I would do here, and this is kind of where we're going to wrap this video up, is I would go to Fabric, and I would confirm topology, right? And topology is not going to show my leaf or spine yet because I didn't register any of those. But I have my APIC controller right here. That's great. It sees itself. Now, this is the beauty of a self-documenting network. I'm going to go to Fabric Membership, and I can see there is a leaf switch. That's the one that the APIC is physically connected to with these ports, ETH2.1 I believe it is. I don't have 2.2 connected, just 2.1. And I'm going to go ahead and register this device. So if I go back to Fabric Membership, and I register, I'm going to give this, I typically go with a 4-node numeric ID for my leaf switches, and a 3-node numeric ID for my spines. So I'm going to call this one 1001. My node name is going to be leaf1. I don't really have a rack here, so I'm not going to designate that, but if this was in a large data center or small data center and you have racks designated, you can actually modify that. I'm going to hit update, and you're going to see it's going to go ahead and configure this and register. Now, the beauty is, when it registers this leaf switch is then attached to a spine. It's going to use LLDP, and it's going to discover the spine, and then I should have a spine node that's ready to be registered in the Fabric as well. So we just got to give this a little bit of time, and eventually, getting back to my self-documenting network, this topology will refresh with my leaf switch that I just registered. So again, we just got to be patient, give it time. It's discovering. It's basically going to give it an IP address from the TEP pool. You can see that happening right here. 172.31.168.64/32. It's going to configure the ISIS routing protocol under the covers, and now I start seeing more stuff populate here. What is this guy? Well, this is my spine. Now he goes, okay, we see a spine here. I'm going to register my spine, and I'm going to call him 101, and I'm going to call him spine 1, and I'm going to update. Now, as all this is occurring, again, I go back to topology. Oh, look at that. I have a leaf switch now. And then eventually my spine will populate here as well. And if you really want to get down to the details, excuse me, you can double click. And this is a much better representation of the picture that I drew. Right, here's Sean's picture. Here is APIC's representation. But again, here's my VGA port, my console port, my SIMC management, my out-of-band management ports that are in a failover pair, my Fabric ports. And it's saying, hey, we got this Fabric port is connected to this leaf switch. So it gets down to the nitty-gritty details on what interfaces are actually connected. I can go into my leaf switch, and I can see that ETH1.1 is enabled. What is it? Well, it's the EPG for infrastructure, and it's showing that a controller is attached to it. That's my APIC controller. Go back to my topology. Eventually, this spine node will register. Alright, it says inactive right now. It's still going through the process. And while that's happening, I'll go back to my leaf, and I can see I have a health score of 84 now. So it's starting to complain, hey, something's wrong. And that's the beauty about APIC. if there is an issue, your health scores will decrement. So 100 is best case scenario, 0 is worst case scenario, and then you have that grade between. So if I go to 80, I double click on my health score and I go, what's causing this? Well, here are the faults. Power supply is shut down, right? Because I'm only using one power supply. And some various other things. If I correct these issues, if I address them, we'll get to a 100% health score. I can now see my spine node 101 is in the topology. So it's discovered. I go back here. Active, yes. Go back to topology. And look at that. Our spine is there. I can double click into my spine. And I can get to a view where my leaf switch is connected to ports 1 and 36 on the spine. And with that, I will conclude this video. I hope you found this useful, and we are going to continue this series. Next step would be to start configuring policy on APIC. Hope you enjoyed it. If you like this video, please smash that like button and subscribe to the YouTube channel, as many more videos are going to be available. Thank you.